All right, so I'm going to give you some examples for subtracting rational numbers. Remember, it's pretty much the same thing as we did with the addition. In this case, the only difference is that we need to be very careful with the signs. Remember, whenever we have two signs, like in this case, we need to make it a positive because we need to multiply the signs, not the numbers, okay? So in this case, it says, find negative 3.27 minus negative 6.7. Use the same rule as to subtract positive and negative decimals as subtracting integers. So the integers are negative 3 minus negative 6. Write the expression in rational numbers. Negative 3.27 minus negative 6.7. So negative 3 plus 3, add the additive inverse. Okay, so a negative 3.27 plus 6.7. We add now 3 2.43. Okay, because 6.7 is greater than negative 3.27, the sum will have the same sign as 6.7, positive. Okay, because this one's bigger. So negative 3.27 minus negative 6.7 is 3.43. How do we do it? Well, we subtracted 6.7 minus 3.27. Remember, the decimal point needs to go in the same spot. So 0 minus 7, it cannot be done. So we need to add a 1. 10 minus 7 is 3. Now this one, the 7 is a 6 because it lent one of them to the 0. So 6 minus 2 is 4. And 6 minus 3 is 3. Since 6.7 is bigger, and if we see right here, it's a positive number. So my answer would also be positive, 3.43. Okay, let's do another example, just to let it be clear. In this case, we're going to subtract rational numbers, but they are fractions, mixed fractions. So the first thing that we need to do is we need to make this fraction, this mixed fraction, an improper fraction. Remember how to do that? That 5 1/3, we need to multiply the 3 times the 5, which is 15. And then we need to add 1. In this case, it's 16. And we leave the same denominator, 16 over 3. Okay? Now we need to do exactly the same thing with the other fraction, right? We have a 4 5 9ths. 9 times 4, 36, plus 5, it's a 41 over 9. We have it right here. So if you see, in this first step right here, we haven't done anything. The only thing that we did was to put the mixed fraction into an improper fraction, okay? But we leave the same signs. This one remains positive, minus, and this one remains negative. What we need to do next, we need to change that sign, or yeah, that will be it. But we need to first find the least common denominator. Okay, if you see, we can turn this 3 into a 9 multiplying by 3. So I need to multiply by 3 both of the sides. So 16 plus times 3, it's 48 over 3 times 3, 9, minus negative 41 over 9. Okay, we need to change our sign. Okay, so 48 over 9 plus 41 over 9. What we need to do is we need to add the ones on top. 48 plus 41, it's 89 over 9. Or how many times can the 9 go into the 89? It can go 9 times, right? 81, and we will have 8 over 9. So the difference of 5 1/3 minus negative 4 5/9 is 89 over 9, or 9/8 ninths. Right? Very good. Let's see a last example. When evaluating expressions with negative numbers, negative fractions, and decimals, what we need to do first is to put everything either in fractions or in decimals. So determine if the mixed number is a decimal that terminates, because 2 and 4/5 terminates. You can use either decimals or fractions to subtract. Remember, if our division or a fraction, when we turn it into a decimal, it's a non-terminating decimal. It means that one of the numbers repeats, one of the numbers other than 0 repeats like for forever. We cannot use decimal. But in this case, we can use decimals. So what we need to do first is we need to put this fraction into an improper fraction. Okay, this one right here. So how do we do it? We multiply 5 times 2, it's a 10, plus 4, it's a 14/5. And we need to make that a fraction. How do we make a fraction? We do a division, 14/5. How many times can the 5 go into the 14? Well, it can go twice, right? 2 times 5, it's 10. So 14 minus 10, it's 4. We add a 0. How many times can the 5 go into the 40? 8 times, okay? Why did I put a decimal point in there? Because my number has ended. So every 0 extra that I added, it's zeros that I don't have, right? So that's why I need a decimal point right there. So it's 2.8. Since my fraction is negative, my answer would also be negative. My decimal would also be negative, okay? So we continue. I have negative 2.8 minus 1.4. Remember, I do the same thing. If I have negative 2.8, I will add the inverse of 1.4 plus negative 1.4. If you see here, this is going to turn into a negative number. And when I have 2 negatives, I need to add them up. So I'm going to add 2.8 plus 1.4. 4 and 8 is 12. We have 1, and this will be 4.2. Okay? Since both of them are negative, my answer would also be a negative. So right here, I have the answer. Okay, let's do it with, instead of converting them both into decimals, let's do them converting them both into fractions. Remember, you can use the method that you want. Okay? If you remember, the first thing we need to do is we need to convert this mixed fraction into an improper fraction. Okay, so I do the multiplication. 2 times 5, it's 10, plus 4 is 14/5. And this 1.4, I need to convert it into a fraction. So I have a whole number, that will be my big number. And the 4 needs to go over a 10, because it's a 10th. And I can simplify this one, right? If I divide it by 2, I will have 2/5. Good. Remember, if we divide 1 by 2, we also have to divide the other one by 2 too. Okay? So I have my fractions. I need to convert them into improper fractions, which I did. 5 times 2, it's 10, plus 4 is 14/5. And 5 times 1, it's 5, plus 2, it's 7. So 7/5. Both of them are negative. Okay, so what we need to do is to just add them up. Since both of them have the same denominator, I only add the numbers and leave the sign. So I add 14 plus 7, which is 21. Okay, so it will be a 21/5, a negative 21/5, because both of them are negative. Okay. So what do I need to do is, how many times can the 5 go into the 21? It's 4 times, and I am missing 1. So my answer would be negative 4/1/5, or I can put it as a mixed fraction, which would be negative 21 over 5. It's either one works for me. Right. I hope that you get this. If you don't, you can see this video as many times as you need. It's pretty much the same thing that we did last unit. The only different thing is that we're doing it with fractions. All right. Thank you for everything, and I'll see you soon.